Well, welcome. My name is Mr. Murphy, and again, I will be teaching you this lesson 6.6 day 2 video and lesson. And so in this one, we're going to be looking more at how to solve exponential and logarithmic equations using some exponential models that we've learned about in previous chapters. So it's important that we remember those different tools, and don't forget all the different properties that we've learned about. So first off, I want you to start with this warm-up. So I want you to pause the video and try doing this one on your own. So this is, again, what we just did in the day 1 video from lesson 6.6. So I want you to pause the video and hit play when you're ready to check to see if you've done this correctly. All right, let's see how you did. So first off, you should have taken, so again, just like in the previous video, I did combine 2 steps in one here at the beginning, because what we're going to do is there's no way to get the bases the same between the 4 and the 6. That's the one thing I always look for first. Is there any way that, so like 4 is the same as 2 squared, for example, but 6, I can't change 6 to have a common base of 2. So that, what we learned about in the first part of lesson 6 day 1, isn't going to, we can't do that. So then the other option would be to take the log of both sides. And so when I take the log of both sides, I recognize that those exponents I can move out in front. So I did both of those steps all in one. So I have 3x times log of the 4th equals x minus 2 times log of the 6, log of 6. Okay, so the next step is to distribute, because I have the x minus 2 in parentheses multiplied by the log of 6. So distribute the log of 6 through. So we get x times the log of 6 minus 2 times the log of 6. And then I want to combine like terms. So I see that I have 3x log of 4 on the left, and I have x log of 6 on the right. So again, I'm going to combine 2 steps in one here. So what I'm going to do is I'm going to subtract x log of 6 from both sides. And when I do that, I recognize that I'd have 3x log of 4 minus x log of 6. Both of those terms have an x. So I'm going to factor that x out. So we'd have x times 3 log of 4 minus log of 6 equals, then we just have negative 2 log of 6. So again, we want to solve for x. So I'm going to divide both sides by that 3 log of 4 minus log of 6. Now remember, to do this on your calculators, I strongly recommend doing this in 2 steps. So in that way you can avoid making any errors with your calculator. So do negative 2 times the log of 6 on your calculator. And when you write down, so use 3 or 4 numbers past the decimal, just so your final answer will be more accurate. And then take 3 log of 4 minus log of 6 on your calculator. Again, making sure that you write down that numbers to 3 or 4 numbers past the decimal, so we can divide those, and then we can round our answer to the nearest hundredth. Always make sure if it says round to the nearest hundredth, that doesn't mean round to the nearest hundredth as you're working through the problem. It means round your final answer to the nearest hundredth. So we get approximately negative 1.51. So hopefully you did well. Hopefully you got that. All right. Let's look at how we can use an exponential model. Let's look at the story problem. It says the diagram shows how a forest fire grows over time. The fire department can contain a 160-acre fire without needing additional resources. But how many minutes does it take for a fire to become too big for the fire department to contain without additional resources? Okay, so that means all 160 acres. Okay, so the first thing, we got to review an exponential model. So remember, an exponential model is in the form y equals a times b to the x power, or we can use oftentimes x, our exponent is oftentimes t for time. So in this scenario, y would represent the total number of acres, a represents the initial amount, the initial number of acres, b would be your growth factor, and t would be your time in minutes. So let's figure out what each of those would be. So first off, our y would represent 160, because remember, that's the total number of acres. So we're trying to figure out how long it would take to the nearest minute for all 160 acres to be consumed. Okay. Now, your initial amount represents, after 0 minutes, there is 4 acres. Okay, after 0 minutes, there is 4 acres that have been burnt up. So that's our initial amount. Now, your growth factor is 1.8. Where did 8 from? Well, if we take 7.2 divided by 4, so again, the number of acres there, or if I take 12.96 divided by 7.2, or if I take 23.3 divided by 12.96, we get 1.8. So in other words, we'd be multiplying by 1.8 each time. So our growth factor is 1.8. And the time is what we're trying to figure out. We're trying to figure out how long it would take for those to be consumed, where they'd be overwhelmed. Okay, so now we have all our pieces, so we can put it in our equation. So our equation, again, you can see up there at the very top, would be 160 equals 4 times 1.8 to the t power. So now we're going to look at how do we solve that for t. Because the only way to solve this is using what we learned about logarithms because we have a variable that's an exponent. So if we ever have a variable that's an exponent, the only way we can solve that is by using logarithms. So the first step is to get the base by itself. I want to get the 1.8 by itself. So I'm going to divide both sides by 4. When I do that, I would get 40 equals 1.8 to the t power. So the next step is we're going to use that property that we learned about yesterday, where we're going to take the log of both sides. Okay, kind of like what we just did in that warm-up. So when I take the log of both sides, we would have log of 40 equals log of 1.8t. And you could even combine these two steps if you wanted to, like I did in the warm-up, where you would even put that t out in front of the logarithm. Okay, but we could combine these two steps if you wanted to. And then again, our goal is to solve for t. So to get t by itself, I would divide both sides by log of 1.8. And now you just do this on your calculator, and you get approximately 6.276. So it would take about 6.3, so it says round to the nearest minute, so it would take about 6 minutes, because the question says about how many minutes does it take for a fire to become too big for the fire department to contain without additional resources. So we would say approximately 6 minutes. So that's all you got to do. So I want you guys to try one. So again, if you need to, go back and watch this example before trying this next one on your own. But this next one says everything's the same, okay? But we want to figure out about how many minutes does it take for a fire to spread to cover 100 acres. So this time, instead of 160 acres as our total amount, we're going to do the exact same problem, except for with 100 acres. And this time it says round to the nearest tenth of a minute instead of the rounded to the nearest minute. So only two differences there. So I want you guys to try this one on your own. So hit pause and then click play when you're ready to check to see if you've done it correctly. All right, let's see how you did. So again, you start that one out the same way, except for instead of 160, we have 100. So the process is still going to be the same. So I start by recognizing that I want to get the base by itself. So don't do the logarithm yet. You can't take the logarithm of both sides until we have the base by itself. So I have to divide both sides by 4. So I get 25 equals 1.8 to the x power. Now the base is by itself. So don't get overzealous there and start doing logarithms too early, or you're going to get the wrong answer. Okay, so now I can take the log of both sides, and notice how I combined those two steps in one here. So I took the log of both sides, and I moved that x in front of the logarithm on the right side there. So we'd have log of 25 equals x times the log of 1.8. So now I just have to solve for x, so I'm going to divide both sides by log of 1.8. So log of 25 divided by log of 1.8, again, round it to the nearest tenth of a minute, we get 5.5 minutes here. It's about how long it would take for the fire to spread to cover 100 acres. All right, so now let's look at this next problem. Now, let's look at the instructions here. It says, what is the solution to the natural log of the quantity x squared minus 16 equals the natural log of 6x? Now, it says after that, it says to check for extraneous solutions. Now, for all of the equations we've been solving, you should be checking your answers just to make sure that it makes a true statement or make sure that it's correct. These problems, we're going to do the same thing, but there's going to be something to look for where it could be an extraneous solution. And as opposed to telling you that now, I'll wait until we get to that point. But I just want to remind you that we do have to check for extraneous solutions. And we've dealt with extraneous solutions in the past. Remember, that means that it's a solution where we didn't make any mistake. It's just that it's not as when we go to plug that solution into the original equation, something happens where it makes it so it's not a true statement or it doesn't work out. So like I said, we'll see why and how that works in just a minute. So the first step is this. We're going to I recognize that we have the logarithm of both sides, or the natural log of both sides, so we're going to use that property of equity to say that, well, we would just have x squared, the values would be equal to each other. Since we have the same logarithms, or the logarithms with the same base on both sides, the values then would also be equal to each other. So x squared minus 16 would equal 6x. Okay, so now the next thing I'm going to do is I'm going to get this equal to 0. So x squared minus 6x minus 16 equals 0. Make sure that when you subtract 6x from both sides that we keep it in standard form. So we'd put that minus 6x in between the x squared and the minus 16. Because then what we can do is we could do, actually we have one of two things that we could do here. We could use the quadratic formula. So remember, we can use a quadratic formula when we're trying to find the value for x, and we have a quadratic, which is what we're working with here. But the other option would be to factor it. Now factoring is always the easiest, if it's possible. And it's always easiest when that first term, the leading coefficient, is 1. And that's what we're working with here. We have 1x squared minus 6x minus 16. So I'm going to use factoring here. So what two numbers multiply together to be negative 16 that add together to be negative 6? Well, as you can see here, that is negative 8 and a positive 2. Because negative 8 times 2 is negative 16. And negative 8 plus 2 is negative 6. So that would factor down to be x minus 8 and x plus 2. Or you could swap the order. That's totally fine. Well, then the next step is we're going to set each of those equal to 0 to solve them. Because my goal is to figure out what values for x would give me 0 in that equation. So my two answers would be 8 or negative 2. Everything seems fine. Okay, I didn't make any mistakes that I can see there. So everything seems fine. But we should always check our answers. And that's what we're going to do here. We're going to check for extraneous solutions. So I'm going to start by putting one of those numbers, let's just use the 8, into the original equation. Okay, so we would have 8 squared minus, the natural log of 8 squared minus 16 equal to the natural log of 6 times 8. On the left side, 8 squared is 64, and 64 minus 16 would be 48. On the right side, 6 times 8 is also 48. So we have the natural log of 48 on both sides. Everything seems fine there. Okay, so that's good. That checks. That works out. Okay, but let's check the other one with x equals negative 2. And before I go any further, we're not going to be able to see all my work, so I need to make myself transparent again. All right, here we go. So the next step to this would be to, again, negative 2, square the negative 2. Negative 2 squared would be 4. 4 minus 16 would be negative 12. And on the right side, 6 times negative 2 would also be negative 12. Now, at first glance, that looks fine. I agree. Natural log of negative 12 equals natural log of negative 12. Good. We're good to go. Well, the problem is we can never take the logarithm of a negative number, or in this case, a natural log of a negative number. Because remember what we're saying. The value there must always be positive because there's no exponent, because remember what they're equal to is an exponent, and there's no exponent that I could apply to e in this case to make that e into a negative number, because e itself is a positive number. So there's no exponent that we could apply to a base when the base is already positive that would make it negative. So there's nothing I could apply to e that would make a negative 12. So this, even though it looks good, it's actually not. So again, since the value of a logarithm must be positive, x equals negative 2 is an extraneous solution. So in this scenario, 8 would be the only solution. Negative 2 is an extraneous solution. So why don't you guys do this? Why don't you guys go ahead and pause this video if you feel confident and work on these two examples if you feel confident after doing that last example. If you need to, go back and watch that last example and make sure that you understand each of those steps, because I want to make sure that you can get as far, if not to this entire, both of these problems on your own. But why don't you pause this video then and work on that and hit play when you're ready to check to see if you've done this correctly. All right. Well, I'm going to leave myself transparent for now because you'll see in the next slide that you're going to need to see the majority of the screen. So let's look at how we would do this first one. So this first one, we have x squared, the log base 5 of x squared minus 45 equals log base 5 of 4x. Again, the logs are the same on both sides, so the values would also be the same. So we can just pull those out and just say that we would have x squared minus 45 would be equal to 4x. Subtract 4x from both sides, and you get x squared minus 4x minus 45. For this one, it would be really easy to do factoring. So we could factor that down to be x plus 5 times x minus 9. And then you set each of those equal to 0, and you get two solutions. Now, at first you get 9 and negative 5. I know you get two solutions right now. But we want to check those. I didn't have the space to check to show the work worked out there, but let's talk about that. Let's start with the negative 5. Now, if you put negative 5 in there, negative 5, when you square that, would be a positive 25, and 25 minus 45 would be negative 20. And on the right side, 4 times negative 5 would also be negative 20. So even though they look fine because they're both the same thing, we can't take the log. There's no exponent I could apply to 5 to get a negative number. So we can't take the log of a negative number. So negative 5 is an extraneous solution. Let's try 9. 9 squared would be 81, and 81 minus 45 would be 36. Just like on the other side, 4 times 9 would also be 36. So both sides, you'd have log base 5 of 36. And that's totally fine. So x equals 9 is a solution, but x equals negative 5 is an extraneous solution. All right, let's look at the other one now, the one that's behind me here. So now with this one, I went about this one a slightly different way. At the beginning, it looks the same because they're both natural logs on both sides. So we can just focus on the negative 4x minus 1 equals 4x squared. Now, I don't want to subtract 4x squared from both sides because you always want to avoid, when you're dealing with a quadratic, that first term being negative, because if you use factoring, it just gets ugly. So let's leave the 4x squared on the right side, but let's add 4x, and let's add 1 to both sides. So now we would have 4x squared plus 4x plus 1 equaling 0. Now, if you wanted to, you could factor this, but the first term is not 1. So you can't just look for two numbers that multiply together to be 1 that add together to be 4. There's not going to be any that work out. But you could multiply the first and last terms and get 4x squared, and try to find two numbers that multiply together to be 4x squared that add together to be 4x. But again, it's not as simple as just putting them in parentheses. Remember, that's where you have to use that box method and go through the factoring out of the box. It works. It's totally fine. You could do it that way if you want. But I wanted to review the quadratic formula. So the quadratic formula in this case would be the opposite of b plus or minus a square root of b squared minus 4ac, all divided by 2a. So to start out with, the opposite of b. So the opposite of 4 is negative 4. So I have negative 4 plus or minus a square root of 4 squared. Well, I'm just going to write down 16. So 16 minus 4 times a times c. Well, a is 4, c is 1. So we would take negative 4 times 1, which would be negative 16. So 16 minus 16 is 0. So under the square root, we have 0. So we would just have negative 4 over 8, which reduces to negative 1/2. Now, if we plug that in to both sides, it works out. It's totally fine. Because negative 4 times negative 1/2 would be a positive 2. Positive 2. And then 2 minus 1 would be 1. And you could take the natural log of 1. On the right side, 4 times negative 1/2 squared, when you square a negative, it becomes a positive. And 1/2, when you square that, would be 1/4. So 4 times 1/4 would also be 1. So you'd have the natural log of 1 on both sides. That's totally fine. So negative 1/2 would be a solution. All right, so now let's go ahead and look on the next screen, and you'll see what I mean about why I'm leaving myself transparent. Because on this screen, this summarizes everything that we've learned about. So if you don't already have those properties, you might want to include these. I would say these are good properties to remember, just to be able to pull back and remember to use these. You remember, you should write down the titles of them. You're not going to have to label which property you're using, but it's just good to know the names of each of those. But I would also include the words, because for these properties, just seeing the symbols there might not be as useful to you. So I would make sure that you write down the word definitions, so in that way you have just in common language what those formulas are showing us. And then it's also, I think, usually pretty good to have an example to illustrate that, because sometimes having an abstract, just a formula, even in words, doesn't make a whole lot of sense. But if you have an actual example, it makes it a little bit more easier to see how or why we would use each of those properties. So I would recommend pausing this video and making sure that you have this information in your notes. Like I've said before, even having like a cheat sheet where you have all these on one sheet or one page, maybe front and back, is also a good and useful tool. So with that, that is the end of lesson 6.6. So hopefully that made sense to you. If not, like I said, make sure that you reach out to me or your teacher to get those questions that you still have answered.